Today's video is going to be about economy, good, better, best on start components and good, better, best on meters. When we get outside, we're going to talk about one perspective for a good hour or so, and you're going to see in real time amp draws where we measure the inrush amp using 3 different meters, and we do that again repeatedly between the SPP7, the KS1, which is the same as the TO5, the 5-to-1, and the soft start. You know, at ideal conditions, we're always searching for best ways to demonstrate transparency, and when we're educating or we're actually explaining to a customer or we're just trying to educate one of ourselves or pass that information down, we want to always show how we ascertain that. In this video, you're going to figure that out. This meter, the meter that we strongly recommend, and if you have the need to have the lowest inrush amps, on how we can achieve that by putting a soft start in there. So stay tuned. We're going to be comparing meters, good, better, best. We have the UE, the field piece SC440, and a field piece SC640. We're going to be comparing these meters to see which one gives us the highest inrush amp when we're checking LRA. Additionally, we have 4 different components here that we will be installing. We have economy, good, better, and best. We have the SPP7S Super Boost, the KS1 Kickstart, the 5-to-1 CSRU2 for 3.5 to 4 to 5 tons, and then we have an ICM 870-32, which is a soft start. So we want to compare what is the difference between Hart Start kits, economy, good, better, and then the best would be a soft start. All right, so we're going to go ahead and take these meters and we're going to compare these meters on inrush amps. We have good, better, best here, and what makes them good to best isn't their price, isn't the reliability as far as, you know, how long it can stay in your tool bag before you have to replace it. None of these are supposed to get wet. None of these are supposed to be dropped. What we want to look at is, you know, sensitivity. If I have a meter that can read a higher inrush amp, then that's going to give more value to the equipment, the customer, and the technician. We want to take those sensitive readings, and if we have one meter that can outperform the other one by giving us a higher inrush amp, then that's the one we want to go with, because most likely that's the most true value that you can have. And so that's where we get into that good, better, best, is which one's going to be more reliable in a sense of that I have a more accurate inrush amp, voltage, microfarads, anything like that. We're going to start with good, and these are brand new, so we're going to unpackage them for the first time. I'm not quite sure if they come with batteries or not. This one here comes with a clamp, has its instructions. That's pretty much it. We're not going to need the clamp, and because we know how to use it, we're not going to go over the instructions. Okay, so they also gave us a sensor or a little probe where we can read temperature. It has a carry case, and then the certificate that it actually has been tested, so we can rely on the data that it is giving us. Got the set of leads. This is nice. Gets this little alligator clip so we can clamp on some things. So all the things that we do not need for the purpose of our demonstration is pretty much everything that it came with the exception of the meter. So we're going to just go ahead and put all this stuff right back inside the bag. Okay, so It comes with a battery in it. Looks like we're already able to get readings here. Okay. All right, we're gonna go ahead and turn that off. Okay, let's go ahead and look at the next one. This is the SC440 field piece. Field piece is a pretty good meter. See, it comes in a case. You got to install the battery. You got the meter itself. It comes with some alligator clip probes. Okay, the temperature probe doesn't come with a clamp, and then we have the set of leads here. We're gonna go ahead and put this other stuff that we do not need back in the bag. Go ahead and move this back up here. All right, so we're gonna go ahead and get some batteries put in here. Got a little Phillips head screw. Just want to back it out. You gotta take both screws out to be able to open up this back. I brought a battery. I preferred a Duracell or some Energizers, so we'll just use one of our batteries here. Okay. Go ahead and run through all the settings, make sure it shows something. What's nice about these is you have the inrush button over here. On the UE, you have the inrush button over here. We'll talk about how to use these. So I don't need my leads on here, so I'm gonna go ahead and just place this back up here. We'll go ahead and open up the next one. This is the SC640. At ideal conditions, we use this meter. Everybody that comes into our company, we supply the equipment, tools that we need. The leads already come on the meter, which is pretty nice. I'm just going to untangle these. And same thing, I'm going to go ahead and test it out. I'm not going to use their battery. We'll just put that back in the case. We'll use one of our batteries here, the Duracell. Take the back off here. We'll get the battery in there. There we go. Battery should last a long time unless you leave your meter on. If you're not using your meter, you always want to make sure your meter is in the off. A lot of technicians forget that. We'll go ahead and go through the settings. Make sure we get a display every time we change the settings. Obviously a lot more options here. You can see it has the inrush button on the side. And so the way you want to store your leads is plug them into the back, and then kind of like little rabbit ears, you just move it around to
the side of your clamps. That's pretty much that. So we're going to go ahead and take these three and we're going to test the start amps on our compressor. We're going to go over how to check those start amps, and we're going to give you a value at the same time using all three meters. So it's going to be like a juggling act where I have all three meters in my hand clamped to the same common wire on the compressor. When we turn it on, we're going to record the inrush amps, and we're going to make sure that those values are stored so we can see what those values are, so we can compare that good, better, best, so you can see what we're talking about. Then we're going to install three different hard starts, and then eventually a soft start, so we can compare again the inrush amps, utilizing each one of those, so we can see the combination of meter along with the certain component, you know, starting component, you know, which one is going to do best for the customer, which one's going to be best for that equipment. So stay tuned. Okay, so the first thing we want to do is we want to come over here and we want to verify what is our information for the compressor. If we look here, we have minimum circuit capacity 32 amps. We come down, we know we're dealing with 410A refrigerant. We got our subcool over here. Okay, we come on down to our compressor, 23.7 run load amps. Outdoor fan motor is 2.8 FLA. And then if we come over here, we're looking for this LRA, which is lock rotor amps, 152.5. We want to make sure that we're not exceeding that, so we don't have a issue with our compressor. So we're going to go ahead and test this out, showing you what kind of values we should look at on our gauges as far as equalization before the compressor comes back on. And then we want to look at which meter is going to give us the highest inrush value. Stay tuned. We got the UE, the field piece SC440, and the field piece SC640. We're going to be testing inrush amps on our compressor. We're going to make sure our compressor is not starting up under a load. We want to make sure our pressures are equalized. We also want to give it enough time when it shuts down to ensure that when it comes back on, we're taking the most accurate start amp possible. Because if you short cycle your compressor, you're not going to be taking an accurate start amp. So we want to make sure our compressor is cool enough, giving it that 3 to 5 minute run or off cycle. So we're going to go ahead and hook up our gauges, and then we're going to turn this off, and then we're going to go ahead and make sure that it's off long enough before we check these start amp values. Okay, we're already set on 410A. We have 134 over 304. That pressure difference, we want that to be equalized when we're testing out our start amps. You see we have a superheat of 17, subcool of 5, and we're not going to go over all these numbers on the gauges because that's not the point of the video. I'll go ahead and remove our panel. Okay, and if we look here, we have our incoming L1, incoming L2, and we have our ground. We have our low voltage run capacitor for the compressor. There's not a dual capacitor here. This condenser fan motor is working on a module. Got all that built into the motor. And we have our contactor. So What we're going to do is we're going to go ahead and turn this off. Go ahead and remove the power. And as you can see, it's starting to equalize already. And what I'm doing is I'm just going to my timer. And we're just trying to give it that 3 to 5 minutes. So we're gonna go ahead and put our timer down. And then what we're gonna do is we're gonna take all 3 of these meters and we're gonna go ahead and clamp them on the common side of our compressor, which is up here at the top. Now you can also add your fan motor into the equation because your start amps on the fan motor is not going to be that high. So if it's hard to get your meter in at the top of that contactor, it's okay to read it down here as well. It's not the most accurate reading. It may be an additional 3 amps, but we're looking for a value that's much less than 154 amps. So 3 amps isn't going to make a big difference. For the purpose of this video, I'm actually going to bring it down to the wires that are coming in here, and I have to get all 3 meters in here so we can read the inrush amps. And I'm gonna have to hold this so we can sit there and get the best diode. So on the UE, we're gonna put it on the V. Got a little squiggly line across it. That's for amps. You can see I'm reading 0 amps right now. We're looking for inrush amps. So when we're ready, that's going to record inrush amps. Same thing on our field piece. We're going to come over here, put it on VAC and AAC, which is volts alternate current and amps alternate current. We have to hit select. That'll give us volts and amps. And then what we're looking to do is we want to hit our inrush and go ahead and clamp it on that same wire. We're going to do it one more time. You come over to VAC or AAC 400, okay? We're going to hit select. That gives us our volts down here, our amps on the top. We're going to hit the inrush button, okay? And we're going to clamp it again right in here. And I'm going to have to balance these meters when I turn this back on. This way I'm getting the most accurate reading. So I'm just going to pretty much hold them up so they're kind of where they're supposed to be, and I'll be able to read that inrush amp when we're ready. So let's look at how we're equalizing. We have 184, 276. So the suction side's going up, the discharge side's going down, and we want those to be equalized as much as possible. And the point of that is you don't want to start up under a load because you're going to have a higher start amp. So we want to give this thing benefit of the doubt and see what it does, and that's why you have that 3 to 5 minute window. Looking at our time here, we have 3 minutes already, so we're still equalizing. We're going to go ahead and only give it 5 minutes, and the reason why is your thermostat, when it calls on a hot day, it's probably going to be every 5 to 7 minutes it's coming back on anyways. So sometimes they don't equalize perfectly, and that's okay. These compressors are built tougher than you think. But you can see here it is slowly equalizing. Contactor is already pulled in, so once we put the disconnect back in, it's going to come on. And so we're up at 191 and 270. So I think by the time we hit 5 minutes, it won't be perfectly equalized. Some compressors do it faster. You know, you have the expansion valve. It's allowing refrigerant to come through, and then the valves on the compressor, and if they're really good, they're not really going to equalize across that compressor through the compressor. However, that does happen a little bit too, but this is obviously evident that, you know, we have really good valves on that compressor. So we have 266 and 195. It's not going to be that big of a difference. But like if you don't do this, you could have that 140 on the low side, 300 on the high side, and you're starting your compressor up where one side's literally twice the number of the other side, and that's a lot of load for that compressor to start up under. So you're going to have naturally a higher amp draw. Plus the compressor has time to cool down a little bit too while we're waiting. Let's look at our time. So we're now at 5 minutes and 12 seconds, and we're 200 over 262. And so we're going to go ahead and stop. And what we're going to do is we're going to go ahead and get ready to plug this back in. I'm going to go ahead and position these where they're going to get their most accurate readings. And what I do is I line up my disconnect and I just pop it in. And if you look here, we read OL on the UE. So I'm going to go ahead and shut this off. We're going to let this equalize again. And we're going to talk about these numbers. We can see this okay, right? So we read OL because it can't even read that value. So if this was your tool of choice and you said, oh, I can't read a start amp, that doesn't mean it's low. It didn't read it. We're going to set that down. Let's go ahead and look at the next one here. Again, OL, it did not read it. These are brand new out of the box, brand new batteries. Let's look at this last one, 137.2. Now, big difference in cost of meter, big difference in the cost of the meter. So a lot goes into our trade when we're talking about, you know, testing the equipment, checking the equipment. You have the caliber of the technician and his experience, okay, and his practices, right, which is what he does every day. You have the equipment, the components that we're putting in, which we're about to get into that. And then you have the tool. And so you have 3 different equations that can give you different results. Put a different technician, a different tool, and a different component, and the equation always changes. And you have to understand this when we're doing second opinions behind each other, that the intentions may not be bad, because if this was my tool and you said, what was my start amp? I don't have a number to even write down, and it's brand new out of the box. If this was my tool and you asked me what was my start amp, I don't even have a number, and it's brand new out of the box. If I use this tool and you said, hey, what was my start amp? I would say 137.2. And when I look at this value with what the unit calls for, knowing that there's not a start component in there doesn't mean that my compressor is going bad. It just means that, hey, you know what? If I put a start kit on there, could I lower that number? And the idea is yes. And so we're going to test it again with different start components to see which one of those gives us the best results. And so where would I put a start component? Well, I would put a start component right over here. There's a lot of pre-drilled out holes for potential relays and additional mounting. Like this is a mounting bracket. So some of these start components, they don't come with any mounting brackets, they just come with a zip tie. You want to securely fasten everything so you leave as much room in your panel as possible. So the first start component we're going to put in, this is called the Super Boost. It's an SPP7S. And what we're looking for is to increase the starting torque, and we want to make sure that that inrush amp drops. So we're going to go ahead and open this up. There's 2 wires, you're going to hook these up to your run capacitor, which is up here. The power's off. We know the power's off, and so we can trust that. We're going to go ahead and take a meter, and we don't need to compare meters here. But what we're going to do is we're going to go ahead and just check and make sure there's no voltage present. And how we do that is we want to use a source of ground, so I'm going to use the cabinet. And what I'm going to do is I'm just going to come up to the bottom of my contactor, and I'm looking for pretty much 0 volts. Now, my capacitor, typically it stores power. So what we want to do is we want to discharge that capacitor and then pull the wires off. We want to check to make sure this capacitor is not a problem. Anytime you read high inrush amps, and you saw that we had a good superheat, good subcool, and the charge was good on this system. It's not that old of a system, so why would we have higher start amps? And we see the need for start capacitors a lot in our industry, even on brand new equipment. And your higher SEER stuff, they typically come with them. We're going to go ahead and just check. Let me get my, open that up. We'll go ahead and get my pair of blue handled Klein wire strippers out of there. I typically just bridge my connection between common and HERM. And what I like to do is I don't like to pull on these wires like this. You can just grab a hold and just kind of pry up. That way we don't open the gap. See how I did that? That's the best way to pull those wires off. We want to come over here to MFD. And what we're trying to do is we want to check the capacitor, and it's supposed to be reading 70 microfarads, and we're reading 70.1 microfarads. So we know our run capacitor is good. So far the equipment's okay. We're just using a very good tool to read start amps. So I'm going to go ahead and connect my capacitor back up. I always push down with my tool just so I can get a better connection. And then you want to kind of just tug on them just a little bit to make sure they don't come off and they're on there tight. And so I know I'm not going to have a future problem that I induced. Connections are all tight everywhere. I have the 11 and 1 down here. Just going to check it on the contactor. I always want to make sure your connections are good. Make sure you don't get any turns out of it. Top side and bottom side of the contactor. And everything's good. Okay, so in mounting this, it's pretty much going to go here. First thing I do is I always wire it up to see where it's going to land before I go mounting it. It doesn't matter which side you hook to common, which side you hook to HERM. It just needs to be in circuit. So I'm going to go ahead and just connect this to the top side of my run capacitor. Just like that. And then we want to see where it's going to land. And it looks like if I strap it in right in this area, I'll be okay. And if you look here, I have a screw here and I have a machined hole here, so this will be where I pretty much use my strap. So you should always carry some plumbing strap, and when you do that, all right, I've got some cutters here. We're just going to cut off a piece of that. And what I'm going to do, so I don't short common out, I'm going to go ahead and unplug my defrost control board. You'll hear the valve shift over. That was a quiet shift because we were equalized pretty good there, 237 over 250. Now I can come in here and I don't have to worry about compromising the low voltage side of my coil. And what I'm going to do is I'm just going to slide this strap in here. And now I put the same screw back in there. You want to take your time on this stuff, you know. You want it to be good, you want it to be right. And so now I can take my Super Boost start capacitor and I could put it in here and get it in there nice and tight. It's got a little clip here too, so you can always run your strapping through there. It looks like it's going to be nice and tight there. So I'm going to go ahead and switch over my chuck to 1/4 inch. Let that hang for a second. And that's in there really good. That's not going to compromise the panel when it goes back on. I'm just going to cut this excess off, and this is a professional installation, which is what needs to happen, you know. And it doesn't take that much longer to do it right. Takes a lot longer to come back though, I'll tell you that. All right, so now our Super Boost is installed. Our pressures are equalized. We didn't test the timeout, but we know that was at least 5 minutes because, and either way, we're pretty close to equalization. So we're going to test the start amps again. We're going to go ahead and move it over, hit select, go ahead and hit our inrush. We're going to go ahead and clamp the same one, the common winding. We want to go ahead and do that with all of our meters. Hit the inrush. Okay, it'll actually say inrush there. Take the UE. Okay. Hit the inrush. There we go. And it looks like everything's ready. We want to go ahead and plug our defrost control board back in. Okay. And might have a little time delay here. So we'll go ahead and take advantage of that time delay. And what we'll do is we'll go ahead and plug our disconnect in. And we'll go ahead and just get ready. I'm going to go ahead and position all these meters to where they're going to get the best reading. And we'll just wait that little time delay out. And so it just came on. And so now we're going to go ahead and remove the meters and see what we got. The first one, we have 130. Is that in view? So it didn't go down that much. Isn't that amazing? The second one recorded 2. Well, that's not accurate. If one's reading 130, the other one definitely can't be 2. And if the UE, I don't know if it caught that, but it was reading 14. And so, again, we read the highest inrush amps on the SC640. It's a very expensive tool, okay? A lot more money to buy this than this. This is more money to buy than that, but we're, again, you know, we want to trust the results. So we looked at the component that we put in. It lowered the start amps a little bit. However, when we tested with all 3 of them, there was still a difference between each meter. So we're going to go ahead and turn it off. This time we'll go ahead and look at our stopwatch. We'll go ahead and hit start. Go ahead and pull our disconnect. We want to go ahead and discharge the capacitor. We want to go ahead and check for voltage. Want to make sure there's no voltage. And we have no volts on either leg. And so now it's safe to disconnect our start kit that we just put in. We go ahead and back out that strap that we put in there. And there's the SPP7. Didn't do a whole lot of justice. And it might work better on other units. And that's just the thing. So we're going to leave this bracket here because we may be able to use it again. We'll see. The next one we have is we have a Kickstart KS1 Kickstart. And this is for 3.5 to 5 ton. And so we're going to go ahead and install this. It has a potential relay. And when we get to the smart board, we'll talk about those potential relays and how they work. So there's a little bit more mounting involved with this component here. A lot more extension on my wire, so I can actually install this further down if I wanted to. But let's see if we can use the same mount up here, if that will work. And it doesn't work. So what we're going to do is we're going to go ahead and remove that mount. I'm going to unplug my defrost control board. That's so when I get in here, I do not short out the side of my contactor to the cabinet. All right, so what I'm going to do is I'm actually going to take this start component and I'm going to mount it a little bit lower in the cabinet. So I'm going to go ahead and get my strap. All this is plumbing strap. Go ahead and cut a piece off. I'm going to come in here, take advantage of one of those screws, or not screws, but holes that they left. All right. That's in there nice and tight. Cut the excess off. Nice professional installation. I'm gonna go ahead and plug in my board just to go ahead and initiate that time delay. It's important to make sure your potential relay get another screw here, 1/4 inch screw. Okay, you heard the contactor pull back in, so that time delay is up. It's important to make sure that potential relay is out of the area of the panel, and also the screw has to be up Gravity does play a little bit of a role in these potential relays. And so, and also make sure your connectors aren't touching the cabinet there. Okay, so now we can see we have the start capacitor, the potential relay, and now we have to wire this up. Now this doesn't take 208 or 240 volt, this is just 120 volt, so we only have to come up here to hermetic and connect it. Make sure my connections are tight. And the other side goes to common. Make sure my connections are tight. And as you can see there, I don't have anything zip tied, so we can just see where the wires are going, and we're not going to leave it in there. And now we're going to test the start amps again. If we look at our compressor, it's almost equalized. If we look at our time, it's been 6 minutes and 30 seconds. And the length of time that we installed that, contactors pulled in. This thing is pretty much ready to go the moment I put my disconnect back in. So that wasn't a very long time delay on that board, so I'm going to go ahead and just there we go. I'm going to go ahead and put my disconnect in. There is a little bit of a time delay right now. Go ahead and get my inrush amps ready. Okay, there's 2, and we want to go ahead and get the 3rd one. There we go. Go ahead and hit inrush amps. That was good timing. All right, so the UE has 12.38 inrush amps. The field piece read OL, and the SC640 read 92.5. So I'm going to hold them up for the camera here. You got 92.5. That visible? Good. You read OL. And the UE read 12.38. So again, you know, you could say, hey, my amp draw is low. I got 12 inrush amps with that new start kit. The other one, it read nothing, right? But then when we look at the SC640, it read 92.5. And that 92.5, that's very important because we went from 130 down to 92. That's really good. And that was done with a Kickstart. So we tried the SPP8, which we read 130 by itself with nothing. It read a higher number, and so we're already getting better with the next level of start component. However, we can clearly see the difference in utilizing a better meter on accuracy. So we're going to go ahead and shut power off and go ahead and turn the gauge back on here. For 134 over 296. I can go ahead and turn this off. Reset the clock. I'm gonna go ahead and hit start. Okay. So we're going off of that 3 to 5 minute window. We want to know what that is, not what it feels like. It could feel like eternity when it's not. It's just 5 minutes. And we also want to look at our values to make sure it's healthy to check these start amps. So I'm going to go ahead and pull the potential relay out. I'm going to pull out the start capacitor and the mounting bracket, and we're going to put the next one in. We want to make sure there's no voltage, so I don't get ahead of myself. Always turn our meters off. Okay, and we're just going to go to one side of our contactor, and we're just going to go to the cabinet, make sure we have no power. All right, the moment we do that, we know we're safe to play with it. we're going to go ahead and just take those wires off. Okay. Take the potential relay out. I'm going to go ahead and leave the board plugged in for now. There's potential relay. Go ahead and put the screw up here. There we go. And now we have removed the Kickstart KS1 Kickstart and set it on the table. All right, I might be able to reuse that mounting bracket. Next, we have the 521 compressor saver. All right, so we're going to go ahead and install this one. Very similar, except this coil takes a different voltage. Again, once we get to the smart board, we'll talk about those voltages and all that. And this one's nice because it gives you a nice little wiring diagram on where to hook everything up at. And so we're going to go ahead and get everything mounted, and we'll wire it up. This one also comes different colors. Some people prefer these because they get the best results. So we're going to go ahead and get our capacitor in there, and looks like everything's going to line up on the bracket, so I don't have to change my bracket out. Makes for a faster swap over. Sometimes you see these things is zip tied in here, and you got to do what you got to do, but always harp on a professional installation. Okay, so on these here, we're going to go off the diagram just to show you, since it was supplied. I'm going to put the potential relay back in there. Okay, potential relay is installed. Run capacitor is installed. See if I can't get a better bite on that. There we go. Full quarter turn there. Okay, it's been 3 minutes and 49 seconds. We're 217 over 265, so we're equalizing. All right, go ahead and unplug our board just so we can take advantage of that little time delay, so I can plug this back in and hold my meters up here. All right, so we have 3 wires. You got red, black, and you have yellow. All right, so we're going to look at the diagram here. And if you look at the diagram, it says we want to go to our stripe wire needs to go to hermetic. Hermetic will be the orange wire. We're going to go ahead and put it on the terminal. Make sure it's nice and tight. So now our hermetic's on there. The next one says the red wire from 1 will come up to the common side of the capacitor, which is in parallel with the run winding. Okay, so we're going to take this side up here, and we're going to connect it to the other side of the capacitor. Okay, as you can see, I'm using my clines to get my terminals on there, and that gives you the best fit connection, so that doesn't create any problems. Last wire is black. It's obviously going to the common side. It says it right there. And that's just coming over to the common side of my contactor. If you look up here, that'll be this black wire up top. Go ahead and there we go. That's on there good. Try to pick up on it. It's nice and tight. All right, and clean the top of the cabinet off so things don't blow around. going to go ahead and plug in our disconnect box. Okay, and at this point we need to go ahead and check start amps again. So we're going to go ahead and position everything back on the right setting. Okay, we'll hit inrush, go ahead and clamp it. Okay, take our other field piece, go ahead and hit select so it can read amps. Go ahead and hit inrush, go ahead and clamp it. And the more you're in a trade, the more money you're going to make, and the more money you make, the better tools you can buy. Go ahead and hit inrush. So right now these things are ready. All right, so we're going to have like probably less than a minute once I plug this back in. But short cycle on me, I don't like that, but because it did that, we're going to go ahead and pull the disconnect out. Okay, everything's pretty much ready to go. All of them are reading the dash lines, which means there's no value. So the moment we plug our disconnect in, we'll do that. So what happened was the contactor short cycled when I plugged the board back in. It didn't run long enough to throw off our equalization. We're 229 over 258, so theoretically, and it didn't run long enough to heat the compressor up to where we're going to get an inaccurate reading. But you know, I'm trying to show you the right way of doing this. So what we're going to do is we're just going to give it 3 minutes, and then we should be able to turn it on, and then we'll see what the value is on these 3 meters with the 521 start component. So, and that'll help equalization too, because we're still equalizing very slowly. I don't expect you to have, you know, the best meter, but it's important to start leveling up. And you don't look at it like, oh, I'm not going to get that meter until my other meter dies. You should always have a backup meter anyway. So maybe if you know there's a better meter, invest in that better meter, and then utilize your other meter, you know, for that rainy day. Maybe you check microfarads and voltage with that. If you do installs, maybe that's perfectly fine. But if you're in service or maintenance and you need to record inrush amps throughout the day, you want to make sure you have a good solid tool that's going to give you those results. And a lot of us, we don't know that because the box says it reads inrush amps. And so that experience that I have that I'm giving you is to illustrate right here that, you know, same wire, same startup, different values. It just kind of shows you that the more money you spend on the tool, the better information you're going to get. Low numbers don't mean they're accurate numbers. A higher number will actually be your more accurate number. Now you could have batteries that are going bad and you just need to replace them, but as you witness, these are brand new out of the box. We installed brand new batteries on all of them, and this is the value that we should be getting. All right, we're 229 over 255. It's been 2 minutes and 11 seconds. We have about another 50 seconds left, and we'll go ahead and kick everything on. And UE is not a bad meter. The small field piece isn't. Typically, I would carry the small field piece and the larger field piece. But if I was going to check inrush amps, I would use my larger field piece, my SC640, just so I can get the highest number that is available for, you know, quality, which we're looking for longevity, account retention, customer satisfaction. You don't want to come back out there because you say everything is fine. Somebody comes behind you, different tool, different level of experience, different start component, the whole thing just changes. All right, so we have been 3 minutes and we're 229, we'll call it 230 or 250. So this will be safe to power it back up and see what these start amps provide. So right now we have inrush ready on all of these. I'm going to go ahead and position the meter where it's going to get the best value, and we're going to go ahead and plug them in. I'm just going to line it up. I'm just going to snap it in with my hand. All right, so the first one, we read OL. The second one, we read OL. And the last one, we read 105. And so if you look at that, again, OL, OL, and 105. And so again, it doesn't mean that I have a problem with my compressor. It just means that, you know, I would leave a start kit on, and I would make sure that that start kit was left in there, because it obviously is giving me a lower starting amp with one in there than without one in there. And you know, voltage is one of those things that fluctuate throughout the day, which can also throw out amp draws too. It's always good to check your voltage. We know we're reading 240 volts on this particular building because we have a lab and we're always testing the power. But just to show you what that voltage is, come to our bottom side of our contact and we're reading 235. All right, so I'll go ahead and put it in frame, the voltage we're reading, 235, and so we're within our specs. So that's the 3 Hart Start kits, that's the 3 meters. We're going to go ahead and install a soft start. This is completely different, different technology. This one actually senses faults and whatnot, so stay tuned. We're going to go ahead and unbox this one and talk a little bit about it. When we go to mount it, we have to make sure that we create space to mount it because it's a tight control panel, and we obviously have to remove our start component. Now, you cannot have a start component in conjunction with a soft start. There's a big difference between a soft start, which is the best you can buy, and a hard start. So you've seen 3 different hard starts. This is the best you can buy. It's made in the US, it's ICM controls. Okay, this thing's sensing voltage, ampacity. It can shut your unit off. It can add a delay on your compressor for better compressor protection. And most importantly, it's going to lower that start amp. It's the best thing if you have a home generator to have one of these on there, and it is not something that can be in parallel with a start kit. So if you have a start kit, you have to remove the start kit to put one of these in. So we're going to go ahead and shut power off, take that start kit out, install the soft start, wire it up. It's only 4 wires, and they have different ones, so you have to make sure. If you look, you see that 32, that's 32 amps. In the beginning of the video, we showed you our block rotor amps and our run amps, and our run load amps were much less than 32. We were in the low 20s, so this was the one that we had to put in for a 5-ton unit for this model unit. So we're going to go ahead and install that. First, we're going to go ahead and disconnect power. All right, things are starting to equalize already. We don't have to use your timer here because by the time we install this, it'll be past 5 minutes. I'm going to go ahead and discharge the capacitor. And your start capacitors have a bleed resistor on them, but our run capacitors don't. So it's always good to try to discharge your capacitors. So now we have the 2 off. We got to pull the common off up here at the top of our contactor. There we go. There's our 3 wires. Go ahead and take our run capacitor or start capacitor out. Potential relay out. So there's the 521. We just removed it. Go ahead and take the strap out of here, the mounting bracket we put in here, that plumber strap. I don't need it anymore. We're going to have to make sure that there's enough room inside this control panel to mount our soft start. We'll go ahead and unbox it here. This cannot be installed outside the cabinet, even though it is sealed, because it cannot have any type of condensation on it. So sprinkler heads that are aimed at the unit will have this thing wet. So basically what I'm saying is you can't mount it down here or on the side of the house just because it looks like it's got a safe enclosure. It's sealed, right, but not sealed from direct water. And so what we want to do is we want to go ahead and get this in our control panel. So I'm going to have to move some of these wires out of the way and get creative. So I've got a group of wires right here. Okay. And the board looks like it's going to be fine. Okay. Yeah, and it looks like everything's going to mount just fine. All right, so we're going to go ahead and put a few screws in it. I'm going to try to aim for some of these pre-piloted holes. There's one here. And it gives us 4 ears that we can screw to our cabinet. So I'm going to use all 4 of them. It makes for a better installation. And I am using self tappers. Not all the holes are going to line up. Okay. So the soft start is put in. I don't have to put that wiring harness back in here. I can kind of leave it in front of this, but I'm going to see how I can tuck these wires around just for a better installation, because we still have to be able to navigate in this control panel when we're doing other things. You always want to try to make sure that you know, you're leaving as much room as possible. Perfect. And it looks like I can put my original screw back in here now. a lot of the times we don't like to teach at the equipment because everything's in the way. You can't really get a clear perspective. That's why we go over different perspectives so you can have a better line of sight on what we're talking about. So you want to stay tuned to the video so we can show you those other perspectives. As you can see here, I'm just moving things out of the way. For now I can see my LED lights that are up here, LED 1, 2, and 3, for run, start, and fault. Okay. That's why I'm very careful about how I want to put this in, so it's nice and clean. I'm going to take some more of these wires, just kind of tuck them out of the way here for a nice clean installation. There we go. Excellent. Everything's nice and out of the way, and we can see everything, which is good. That's what we want. Move these low voltage wires out of the way. Now we just have our high voltage wires here that we have to hook up. Now it gives you a wiring diagram on it. Also, we can refer back to the paperwork that it comes with. Go ahead and put these pieces in there. And so I'm going to have to put connectors on every one of these. So I have black, blue, brown, and red. And so they give you an instruction booklet with 3 different configurations. The configuration we're looking for here is configuration 3. In configuration 3, this is for a train, right? And so they want black going to common. They want to splice in the run winding, okay, into the brown wire, okay, and then they want us to take the orange winding, the start winding, which is orange right here coming off the run capacitor, that start winding, they want it to have blue tied into it in parallel. So it looks like we're sensing voltage on hermetic, so we're searching output on the capacitor. All right, and it looks like the run winding is going through the soft start, so it can sense ampacity, right? And also it can drop, it looks like it might be able to drop that leg out in the event there is a fault, just like your contactor can drop a leg when it turns off. And yeah, so brown is spliced in. It's sensing red off of common. So it's sensing voltage coming into the cap, voltage coming out of the cap, ampacity, and it's sensing voltage on the common side of the contactor for the compressor. All right, so we're going to get some connectors. And we're going to get a wire nut. So you got to make sure you're using the right gauge connector. Just kind of twist it on there when you see the strands come through. And you can pretty much crimp it on there. I always leave my crimpers on there, and I snuggle my wire to make sure nothing moves. Everything's nice and tight. Okay. All right, so the blue, they want to sense voltage coming off the hermetic side of your capacitor, which is where our start winding is connected. So I'm going to go ahead and connect to here. So there's our first wire done. Okay, they want black to common. All right. So we'll go ahead and put that connector on next. Twist on my insulated connector. Go ahead and crimp it. Excuse me. As I'm crimping it, I'm going to tug on the wire, make sure it doesn't slide out of there. That way I know I have a good connection. Klein makes really good tools. It's always good to invest in Klein. All right, now this is going to come up, and it's going to come up to the left-hand side of my contactor. So we're going to go ahead and tie it on back here in the back. And all it's doing is sensing voltage, because it's in parallel. Anytime it's in parallel, it can only sense voltage. Anytime it's in series, it's sensing amp draw. We have two left. We have our red wire. Red is going to be in parallel with common on the capacitor. All right, so we're going to go ahead and tie in to the common side of the capacitor. That's not the same as the common leg on the compressor. Two different commons there. I'm going to pull on my wire, make sure I have a good solid connection. We're good to go. I'm going to go ahead and tie it into the common side of that capacitor. Okay, so now that's sensing voltage in, sensing voltage out, sensing voltage out on the common leg. Okay, and now we have the brown wire. Where's the brown wire go? All right, looks like here they want brown to be spliced in with the run winding. So what they mean by that is we're going to have to take the run winding off the top side of this contactor, and we need to splice it in here. So what we're going to do is we're going to go ahead and just take out the red wire, heavy gauge red wire. It gives us just a little bit of slack here. All right, we're going to go ahead and make sure you put this screw back on the contactor, because if not, that whole top side will be loose and you'll have a burnt connection there. We're going to tighten that back down. So this is going to be in series with the brown wire. All right, so we're going to go ahead and cut that. I'm going to strip it back. Go ahead and twist the strands. And they just want us to put a wire nut there. We're going to marry the two up and take a wire nut. So I'm going to get a good gauge wire nut, like a big blue or a red. I'm actually going to take this wire nut off of this here and just go to show you that I can add more wire inside of this wire nut. So that first one that I held up, just because it's available doesn't mean that I'm going to use it. I just wanted to show you that. So we need to get the proper gauge wire nut. As you can see here, that's barely enough to fit one wire in, let alone two. So it's very important to make sure that you're getting good gauge wire nuts and good gauge connectors to make sure that you know, you're getting the proper connections. Okay, so I'm going to go ahead and take the red wire nut. Put that on there. Another good thing to do is take some electrical tape and always wrap it around your wire nut and wire so you have a good connection so it doesn't back out. These are, anytime you're going to have a splice, you want to make sure that your splice is something that doesn't have to be messed with again, because typically spliced wires you don't undo. So we're going to go ahead and just run some electrical tape around our brown and our red. Now these soft starts are not cheap. they wholesale for hundreds of dollars and would retail for hundreds of dollars more. And so they're not very popular because of the price. However, if you have like a home generator or something and they're telling you that you need a soft start, do not confuse yourself with them thinking that they meant to say hard start, because there is a difference between a hard start and a soft start, as you can see here. So we have a very good splice. That's a grade A, that's an A+ right there. So now we don't want to just cram these wires in there, right? What we want to do is we want to go ahead and just make sure, let me go ahead and push some of these in here a little bit further. And what I like to do is kind of fold it, but don't take the loop here and you know, fold it too tight. You want to leave a little bit of that loop open, okay, so we don't create any resistance there and that wire will heat up and have a melting point. Okay, so all right, so we're going to take a zip tie and we're going to go around this clump of wires. There we go. And now the next thing that we can do is we can come up and we can zip tie it again back to itself, kind of in this little area. Make sure that it's going to be out of the way, not complicate anything, so you can still get your tools in there and get your readings, whatever you need to do. You know, give it a nice, good, professional installation. See, all I did was I just really zip tied it back to itself, and so it's kind of floating in there a little bit, and that's okay, because you know, you need to be able to maneuver some of this stuff. And so now this wire that I have way down here at the bottom is where we're actually reading our start amps. It's pretty good. Let's see, I'm going to add one more zip tie to it. Always cut the excess off your zip tie. Your control panels don't give you a whole lot of space, so again, you want to give it a nice clean installation. Okay, so we can still read our start amp that we've been trying to do this entire time off that one wire, which is right here, which is actually, if you follow that up, it's the common side of our compressor. All right, so we'll just overlook all of our connections to make sure they're good. We have blue on the hermetic side, we have red on the common side of our capacitor, we have black on the common side for our compressor, and then we have our run side, our red and brown, spliced together just like they wanted. And I have that just kind of tucked back here out of the way. And so at this point we can now see what that amp draw is, and you know, check out this soft start. So we're going to go ahead and take our field piece, we're going to put it back on, volts, alternating current, hit select so we can read amps, hit inrush, go ahead and clamp it, get it ready. Go and take the UE. Go ahead and get it ready. Okay. Go ahead and take the SC640. And go ahead and get it ready. And now we'll just verify that all the meters are on standby, they're all ready. Okay, they're all ready. All right, and we're going to go ahead and put power on it. I just kind of line up my disconnect, pop it in there. You saw there's a little bit of a delay there. That little bit of a delay was the soft start. So let's go ahead and look at each one of these. Inrush amps, 7.5. Inrush amps, 9.9. And inrush amps, 19.4. So I mean, let's just look at this. 9.9. Is that in view? 9.9. It's amazing. Let's look at this one. 7.57. Now remember, this one always gets us the highest value because it's the most sensitive, 19.4. So which one do you think I'm going to leave in there? That one. So that just goes to show you that, I mean, 19.4 is obviously higher than the 9.9, right? But 7.57, I mean, every one of these are consistently low. Every one were consistently high. Just in every case, I got the most accuracy of a reading out of the SC640, which is why this is a powerful tool to stock, right? But every one of these showed a good value when we installed the soft start. And that soft start is not to be in comparison to a hard start. It is a difference. And you saw when I turned it on, it had a little bit of a delay to it, but it did all on its own.
That was pretty interesting, that perspective. We got to see everything we needed to see. The SC640, very good meter. The soft start, very good component to reduce those inrush amps. Consistent values were expressed on a lot of videos, especially this one. The only consistent value that you had, it wasn't on the start component, right? And it wasn't on the meter. The consistent value that you had was the person that was talking about it, the person that was checking all these things. We get inconsistent values on every call. No two calls can be ran the same. And it doesn't matter if they're all the outdoor temperatures that were consistent throughout the day. The moment one company runs a call, another company runs a call, someone's next call on that list to run will impact the decisions they make on that call. How long is the drive? What do I think it might be? Do I need to get something on the way over there? Patience is a virtue, right? It's not a common virtue though. Also, what's going on in our livelihoods, what's going on at home, what's going on at work. All those things are inconsistent, right? And so you can have two different caliber technicians, two different caliber companies. So when we start looking at how can we get some consistency here? Well, we can do that through the tools that we use, the training that we receive, the level of patience that we acquire, and how we train our brains to work, and the components that we use. So we hope that in this video, you were able to ascertain that, get that out of it, and hopefully that helps you level up. Thanks, we appreciate all your support. Like our channel, definitely subscribe if you haven't done so already. We release videos all the time. Our job is to pass knowledge down the best way we can. This video supports that. There's a share button. That's how you can help that happen. Leave a comment, we read them. We have many subjects to cover. Stay safe, stay tuned.